Okay, so let's go ahead and finish this up. We're on the bottom of page 572 where it says, putting it all together, one sample z-test for p. One simple z-test for p, okay? Significance test, four-step process, the same thing we just did, right? State, plan, do, and conclude, okay? So one sample z-test for proportion on the other page, page 573 on the bottom. There is a green box there. Go ahead and read that. The z, finding the test statistic there, finding the standardized test statistic, okay, how to find it. And then there at the bottom, there is the three different types of ha. You can have one that is greater than a p, ones that is less. Those are both one-sided. And then there are the two-sided ones. Those are the ones where the whole would be something like p is equal to 0.8, whereas the ha, the p is not greater than 0.8. I don't really care whether it's greater than or less than, okay? All right, when it's not equal to, when I have that sign, okay? All right, so that would be the two-sided. And we'll talk a little more in depth about that, okay? Flip the page, let's see if we can go to do the example. The example, one potato, two potato. Okay, recall that the potato chip producer we met in section 9.1. Okay, this is the guy who was doing the potato chips, bringing in the truckloads of potatoes, right? And they were testing for the potatoes, correct? Okay, and the main supplier agreed that each shipment of potatoes must meet a certain quality standards. If the producer finds convincing evidence for more than 8% of the potatoes in the shipment are blemishes, and the truck will be sent away. Otherwise, the entire truckload will be used to make potato chips. The potato chip producer has just received a truckload of potatoes from the supplier. Supervisor selects a random sample of 500 potatoes from the truck. Inspection reveals that 47 of the potatoes have blemishes. Is there convincing evidence at a 10% level that more of the 8% have blemishes? Okay, so what do we have? We have the whole is that we have P is equal to 8%. 8%, P is equal to 8%. And we are thinking because of when we checked out of 500, we have 49 that had blemishes. Okay, by the way, the alpha level here was 10%. So what we're thinking is that the P is greater than 0.08, right? Because we have evidence here that it's almost 10%, right? Okay. So it's actually going to be what? 9.8%, right? So this is going to be 9.8%. Okay, so now we're going to do the test. Let's do the test. So the state is this. We are doing a significance testing with a whole of this, half of that, alpha level of 10%. Okay, and then we have the plan. Okay, plan. Is it a random sample? Yes, we're doing a random sample. We were told we're doing a random sample. 2, we are taking 500, which is less than 10% of the entire truckload. And then we have 3, we have NP N times 1 minus P. Both of these are greater than or equal to 10. So the large counts is satisfied also. Do. Let's find the test statistic. So the test statistic, the Z standardized test statistic is, we have this guy here, right? 0.098. 0.08, this is the one right here, 0.08. We're going to have 0.08 times 0.92 N. Okay, if I do that, what do I get? I am going to get, well, this is 0.9. Was it 47? Oh, it's 47, never mind, 47.98. So it's not, it's 0.94 actually, right? 94, so this guy here would be 0.094, okay? So I do this, what do I get? I get 1.15, 1.15. So it's greater than that, right? So if you look at it, we're looking for this guy right here. Okay, so I would do a norm CDF, 1.15 to 100, 0, 1. Right? And if I do that, what do I get? P-value of that, 1.5, I get 12.51, 12.51%. 12.1 is my p-value. This is my p-value right here. My p-value is 12.51%. So I compare the p-value to the alpha, and lo and behold, my p-value is greater than the alpha now, which means that I cannot reject the whole. Doesn't mean I accept the whole, right? We never accept the whole. So I failed to reject the whole. I do not have convincing evidence that P is greater than 0.08. Okay, which means that what? I'm going to receive that truckload and we're going to go with it. Okay. So conclude, because our p-value is greater than the alpha, we fail to reject the whole. There is not convincing evidence that the true proportion of the blemishes of potatoes in the shipment is greater than 0.08. Okay, just as we said. All right, so let's go ahead and flip the page. Okay, there's something interesting there on page 575. Okay. Says, what happens if the data does not support the HA? If the data does not support the HA, there's no reason to do the test, okay? It's always going to fail, okay? If the initial data does not support it, okay? All right, and that's what they're stating there. Okay, so that's that. And go to page 576. On page 576, it gives you the technology corner. It tells you how to do this using your calculator. So in your calculator, when you go stat, and you would go tests, and you would find the one prop Z test, one proportion Z test. Now, if you look there, it tells you you have to input the P that is associated with the whole. Okay, and then the 47 out of the 500, the X and the 500, the N. And then the prop, the prop there is that, okay, you have less than or equal to, less than or not equal to or greater than. So you're looking at a greater than here, right? Because you're greater than the 0.08. We were talking about greater than 0.08. Okay, and we will just go ahead and enter that. And it'll give you the Z value, and then it'll also give you the P value. Okay, the P value there is what? 0.1242, right? So it gives you the P value. Okay. Now on page 577, we're going to talk about the two-sided tests. So let's look at the non-smokers there and see how the two-sided test differs from the one-sided test, okay? So example is non-smokers. According to the CDC website, 68% of high school students have never smoked a cigarette. Yanhong wonders whether this national result holds true in her large urban high school. For her AP Stats class project, Yanhong surveys a sample or a simple random sample of 150 students from her school. She gets a response from all 150, and 90 say that they have never smoked a cigarette. Is there convincing evidence that the CDC's claim does not hold true? Okay. It didn't say whether was it larger or was it smaller. It just says whether it holds true or not, right? So the Ho is going to be 0.6, right? 60%? 60%? 68%, I'm sorry. 0.68. And here's the difference here. So the high is going to be that the P is not greater than or less than, but it is just not 68%. Okay, so the state would be this. So you're stating this, and you're going to do a significance level of what? Does it give you the significance level? It does not. So in the absence of a separate significance level, we are going to use 5%. Plan. So yes, we're doing a random sample. 2, we only did 150 out of a large high school. 3, and we're gonna have NP and 1 minus P, right? And these are both greater than or equal to 10. So we're gonna be good with the large counts. So let's go ahead and find the test statistic. Test statistic is what? So she did 90 out of 150, right? So 90 out of 150 minus 0.68. Oh, so this is 0.6. So we're in a negative number here, okay? And we're going to get this. And N was 150. 0.68 times 1 minus 0.68, 0.32. And if we do this, we're going to get negative 2.1. Negative 2.1. So negative 2.1. So now here's the difference. So negative 2.1. So you're going to go like this. This is 0 here. This guy here, we're going to find the norm CDF to define that. But then you have to do two-sided. Okay, so whatever you find, you're going to multiply that by 2 to find the p-value. So the p-value itself is going to be, 2 times norm CDF, negative 100 to negative 2.101. Okay. And if you do this, you're going to find what? 0.0, so it's 2 times 0.0179, which is going to be 0.58. Okay, so this is my p-value. Now, so the p-value, again, was 2 times this tail here. So I have 2 tails because the ha was not equal to 0.68. The ho was 0.68, right? So again, so my p-value is this. So my p-value is still less than the alpha, which was 5%. So p-value is less than alpha, which means that we reject the ho. We reject the ho, and we have convincing evidence that the true proportion is not equal to 0.68. Okay, So that's how you conclude. Conclusion, because our p-value is less than the alpha, we reject the whole. We have convincing evidence that the proportion of all students at Yano School who would say they have never smoked a cigarette differs from the CDC's claim of 0.68. Okay? And that's it. We're done. Okay. So, okay, well, before we say down on the page 379, it says, why convincing confidence intervals give more information? So I did the significance testing, right? And in the end, what have I found? I found that, okay, the P is not 0.68. Well, it's kind of nice, but it also isn't nice because I don't know what it is. I just know, I just did all this stuff and I found that the P is not equal to 0.68. Whereas if I did a confidence interval, right? If I do a confidence interval, I get an actual interval and say within this interval, right, the true proportion mean is going to be there somewhere, right? We're going to capture the true mean there 95% or 90% of the time or whatever it may be, right? So that's why it is better to do a confidence interval, okay? Well, not better, but it gives you more information. And, okay, now we're done.